Okay, so this is kind of just like a recap of arithmetic and geometric sequences, and we're also going to revisit the recursive and the explicit rules for your quiz tomorrow. So after you've made both of these, or all three of these bubbles, can you just put your pencil down and just watch me work this out? Normally I would have you guys make the double bubble, but since this is kind of a review and we're going to compare and contrast, I'm going to do it and then I'm going to let you record. Because if you guys are writing, I'm waiting for you to finish writing, and it just goes a lot quicker this way. Okay? All right, everybody's got pencils down. I'm going to do my color to this thing later. Okay, so the first thing I'm going to put on this is that when we're talking about a double bubble map, we're talking about comparing and contrasting. So the first thing I'm going to say, well, recursive rules and explicit rules are used for, both of them are used for arithmetic. So they're connected to both. Of course, these are both rules. And then the other one is geometric. Both explicit and recursive. But when I'm talking about the recursive side, and I'm talking about arithmetic, it has its own rule or formula, which is a sub n equals the previous term, and then I'm going to add my common difference to it. But if I was talking geometric, my recursive rule would be a sub n, and then my previous term, but I'm going to multiply it by r, so I kind of want to put the r in front. So do you see how you can kind of see the similarities in both of these? So they both have some term. They both have the previous term. And this one uses r, and this one uses d. Now somebody brought to my attention that they are kind of confused about what the r and what the d are. All right, they're basically the same thing. When you're taking, and I'm going to erase this in a second. Let's do it on the next page. These are your terms, and these jumps right here, how much you have to add or subtract would be the d, and how much you have to either multiply or divide to get to the next term is your r. So that's the only difference. Does that help a little bit? So r and d are the same thing. They're both the amount you have to jump. So if I have to add 2 each time I go to the next term, like this, 2, 4, 6, 8, 10, then I would use, I'm adding as I go, so I would use d, and I know my common difference is 2. Now let's change it. If I said 4, and then 8, and then 16, and 32, I'm no longer adding, I'm multiplying. So instead of using d, I would use r, but it's still 2. Does that make sense? I use d. If I see the letter d, I know, oh, this one's arithmetic. We're adding or subtracting. If I see r, I say, oh, this one's geometric. We're either multiplying or dividing. So there's the difference between those two letters. But they both are what you do to get to the next term, what you use to get to the next term. Does that clear that up just a little bit? Okay. I think it'd be easier if they use the same letter, but kind of when you see the letter, you know which one you're dealing with. You know you're dealing with adding or subtracting or multiplying and dividing. Okay, so let's go back here, and there's one more thing that I want to add to recursive. Recursive, that key word is previous term. Recursive is very, very limited. because it only talks about the previous term and the term you're on. The only other piece of information that the recursive rule will give you is D or R. Okay? So let me go over on this side. So for explicit, my rule for arithmetic is for some term, I'm going to start with the first term, and I'm going to add or subtract what I need to do to jump. And then my geometric rule is to find some term. I'm going to start with my first term, and then it talks about what I need to do in order to jump. Now the explicit, it may deal with the previous term, but that's not what I'm looking for. What I'm looking for when I first try and figure out whether it's explicit or recursive is I'm looking for that first term. Now before I talk about that, let's go back to here. So between the geometric and the arithmetic, look, they're the same. They've got to find some term. They both have the first term, only this one deals with R and subtracting 1 from how many spots we have, and this one deals with D and subtracting 1 from how many spots we have, or how many terms we have. So between these two, the only difference is this one talks about the previous term, this one talks about the first term. So let's recap before you write this down. So the first thing you want to do when you're trying to figure out whether it's arithmetic or whether it's geometric is look for add, subtract, or multiply, divide. That right there will either tell you whether or not you're dealing with this stuff up here or this stuff up here. Secondly, if I want to know if it's recursive or explicit, I immediately go to this formula over here and say if it's explicit, it should be giving me the first term. That's what I look for. If it doesn't give me the first term, I know automatically it's this one over here. So we're going to work with this and do some examples of this. So go ahead and copy that down. I'm going to go ahead and color code. Recursive, 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 explicit, explicit, explicit. And these are the ones, they're both rules. Does that help? So now you have this chart in front of you, or this bubble map. So let's use it to reference as we do this activity. Okay, so the first activity we're going to do is we're going to talk about whether or not it's arithmetic or geometric. So remind me, what am I looking for if I'm just looking for whether it's arithmetic or geometric? I'm looking for addition and subtraction or multiplication and division. All right, so right away if it's addition and subtraction, it's going to look like these. And if it's multiplication and division, it's going to look like these. Okay? But both types, like let's say it's multiplication and division, it could be one of these two types. I've got them all mixed up in here. All right. So, oh, that reminds me. Do you need your little response? Paddles that have the red and the green. So get those out, and we're going to use those. Okay, so I'm going to ask myself, is it arithmetic or is it geometric? I look at this, and this just says to find some term, I'm going to multiply 3 times the previous term. Did it say anything about the first term? As you're doing these, you should do what I'm doing. I read it to myself. So did it say anything about the previous term? And then I'm doing it to myself again. We're only talking about arithmetic and geometric, so the only thing I'm going to concentrate on that on the next slide. The only thing I want to concentrate is it multiplication and division, or is it addition and subtraction? This one only deals with multiplication, so this one's geometric. Okay, so you should have had your green paddle. Let's try another one. All right, so tell me, is that arithmetic, addition and subtraction, or is that geometric, multiplication and division? Need everybody show me a paddle. Okay, we almost all of us agree on this one. Good. So that one is, I have addition right here. Let's try another one. Got this one. Arithmetic or geometric? I think we only have one person that doesn't agree. So this one, we're just dealing with, I think some in the last class were getting confused about this down here. There's some subtraction in there, but that doesn't count because that's just part of the subscript. Anything that's small like that, if you've got an addition sign or a subtraction sign, that does not mean we have addition or subtraction in the formula. That just is talking about whether it's the term we're working on or the previous one. That's all that means. So the subscript doesn't count. It's almost like, I could even say, not even use that and just say previous. It has nothing to do with math. That subscript has nothing to do with math at all. Okay? All right. So this one is multiplication or division, which means it's geometric. You want to get some water? You sure? Okay, show me. Is that arithmetic or geometric? We should be able to do this a little bit faster because you guys are doing good. Awesome. That is multiplication. Another one. Better. It's got a subtraction sign there, so that one is arithmetic. And that one? Almost 100% on that one. Again, you've got addition here. So that one's arithmetic. Good. I think we're at 100%. I didn't want to do that. I just want to -4. This one's tricky. And I didn't mean to be so tricky. But here's the reason right here. I'm going to do it on the board. This one is actually, look, if you match it to the formulas over here, which one does it look like? The orange or the blue? Looks like this one right here, doesn't it? What's it missing? The a sub 1. When I add nothing, what does that look like when I add nothing? See why it's tricky? There's actually a first term there, it's just 0. And this one? I hope that didn't stop my recording. What do you guys think about that one? Okay, so I caught you in the same trap on that one. Look at what it looks like over here. Which one does it look like? The orange or the blue? Orange? None of the oranges have an exponent. It has an exponent, so it must be geometric, right? Has to be geometric. So that first term is 1. All right. Okay, so you guys tell me with your paddles, be honest, is this helpful? Yes or no? Okay, and I'm getting some of you, I like that. The whole going back and forth, that means maybe, iffy. Good, so. All right, let's try it with the recursive and explicit. All right? Remember, if you need to, use these up here, right, if you want to decipher between them. And then recursive, let's remind ourselves from our bubble map, what's that key word or that key fact in the recursive? Previous term. What's the key one in the explicit? First term. So if you see a first term, you don't even have to worry about whether or not it's talking about a previous term. Just think about that. If there's a first term in there, it's got to be an explicit formula. Okay? Let's try it. Uh-oh. All right, so is that recursive or explicit? What did I tell you to look for? First term. Can you find a first term? And if you can't figure out whether it's geometric, if you're trying to like match it up with these, what could you look for? What's this one deal with right here? Addition or subtraction, and what does this one deal with? Multiplication or division. What does this one deal with? Multiplication or division. So you go and you look at these two to figure out whether it's recursive or explicit. Kind of easy, right, when you think about it. Once you eliminate these, when you look at these, the real big difference between them is this one has exponents, right? This one doesn't. This one just talks about R in the previous term. That's it. Okay? So can I see my paddles now? Is that recursive or is that explicit? This right here. When I'm standing here, I'm kind of like standing in front of that, huh? Paddle. Okay, so you guys are still 50-50 on this one. All right, so that one is recursive. Does it talk about a previous term there? Are there any exponents? No, it has to be recursive then. Okay, if they're confusing you, just think about that first term. Let's try another one. Okay, what about this one? What are you going to ask yourself? Okay, we're still split. It's explicit because, I'm going to highlight the first term for you. There's a first term. Okay, first term, explicit. Let's try another one. What do you guys think? Show me your paddle. Recursive or explicit? Okay, better. Better. It's just talking, there is no first term. It's just talking about the previous term. That's it. That's just how much to multiply by the previous term, right? So it must be geometric because it's multiplying. Let's try another one. Okay, we're not at 90%, but we're approaching. So I see a first term. That would not make it that. Sorry. I see a first term, therefore it must be explicit. Again, we're like 75%. That's recursive. There is no first term in that. It's only talking about the previous term, and then I'm going to subtract 5 each time. Did it again. Okay, this one. Come on, I want 100% on this one. Parse that. This one. Is it recursive or is it explicit? Oh, you're going to actually answer me. Okay, I only have 2 of you in the room that didn't get that one right, so you guys are doing good. This one is explicit. Parsa, why do we know it's explicit? What specifically in here tells me that it's explicit? Before. There's a first term. Good job. About that one. Recursive or explicit? I think I only have 3 of you that are off on that one. I don't see a first term, do you? Only information it's given me is I have to subtract 4. That's it. Is it Michael? Michael, are you going to have a hard time seeing back there? Okay, you're just trying to make sense of it? Okay, I just want to make sure. This one. Wow, I'm surprised. That was one of those tricky ones. Does it have a first term? It does. What's the first term? 0. There's a 0 here. How do I know there's a 0 here? Because if this was explicit and geometric, then there would be an exponent, right? It's not. It looks like this one down here. Correct? So it's arithmetic. That means it's missing something. It's missing that first term. If there's nothing there, it means it's a 0. You guys are probably already on to me on this one. That last one. Is that explicit or recursive? No, I got you on some of that. Got some of you on that one. The exponent? That means there's the first term. What's the first term? But with multiplication, it's not 0, because if I multiply anything by 0, it would be 0. So that would be 1. So a to the n plus 1 equals 1. My first term is 1. Okay, so let's use this a little bit more. I want you to get your whiteboards out. And I'm going to tell you exactly which one I want. I want the explicit. So this exercise is a little bit different. I'm telling you I want the explicit, right? So you would go to the explicit side of your bubble map. And now you just have to figure out whether it's recursive or geometric. Okay? So what's the key when I'm trying to figure out whether it's recursive or geometric? What's the key word? First term or previous term. So that's what you're looking for in these. Okay? Actually, I said that backwards. I need to know whether it's geometric or arithmetic. Sorry about that. I already know it's explicit, so I already know it's going to be talking about the what? First term. Now I just have to determine whether it's multiply or you have to figure out whether it's talking about adding and subtracting or multiplying and dividing. Okay? So I already know we're going to talk about the first term because it's explicit. Now I just got to figure out whether or not it's arithmetic or geometric and write it out. So go ahead. You want me to do this first one for you? Okay. So I need the explicit rule. So I'm going to go over here to my explicit rule and I'm going to say the explicit rule. First I need to figure out whether or not I can find adding and subtracting or multiplying and dividing. To find some term, multiply. Right there. Multiply. Okay, so if I go on my bubble map and I know I'm talking about multiplying and dividing, then I need to go to my explicit, which deals with the first term. I'm going to go ahead and write that. To find some term, I need the first term. I need r raised to a power of n minus 1. So now I say, okay, this is the formula I'm going to use. Now I just have to substitute any pieces that I have here up on the board. So to find some term, multiply the previous term by 2. So I know r is 2. I'm multiplying by 2 every time. And the first term is negative 1. So if I substitute both of those pieces of information back into my formula, I would have a sub n, or for some term. I take the first term, which is negative 1, and I'm going to multiply 2 for however many times I need to jump minus 1. You guys ready to do one? Okay. All right, so this time we're using the recursive rule. So now you just have to figure out whether or not it's arithmetic or geometric and use your rules. So we're using the recursive rule, so go. Good question. When you take the quiz, you're going to have these 4 formulas on the top of the quiz, okay? But they're not going to tell you whether or not they're multiply and divide or add or subtract. And I don't even know if they're in the right order. So you've got to pick apart which ones are which. So I was talking about possibly, I told Devin in the last class, maybe I'll give you guys even a index card. And when you figure out whether or not you're adding and subtracting or multiplying and dividing, you could cover 2 of them up because you don't need those 2. You know what I'm saying? And then what's the key factor to tell me whether it's arithmetic or geometric? Addition or subtraction, multiply, divide. So you should be able to eliminate the other 2 and know which one you got to use. Okay? Was there another question? Yes. If you put notes on the margins of the quiz, like once you get that quiz, you want to write notes down? Absolutely. At that point, it is your quiz. Okay? All right. Perfect. Okay. Do you guys do this one? Okay. So we're dealing with recursive. So now all I have to do is figure out whether I've got division in here and multiplication or adding and subtracting. So I say to find some term, divide. So I know I'm using geometric. Geometric recursive is to find some term. I just have to multiply by the previous term. So it tells me that the previous term, it says to find some term, divide the previous term by 3 or multiply it by 1/3. Okay, so we learned that we don't divide to get to the next term. We multiply by a fraction, right? So my r is 1/3, and it gave me the 5th term is 18. Is there room in here for the 5th term? Do I need that? I don't even need it. This is all I need, right? So to write this formula, it's just find some term. I'm going to multiply 1/3 times the previous term. Yes, Philip? Absolutely. It just looks kind of funky. But it means the same thing. Right? Multiplication is commutative, right? So you could do either one. You could take the last term and multiply it by 1/3. Okay, let's try another one. All right, write the explicit rule. This one's going to be explicit. Wrong color. The explicit rule. You figure out whether it's arithmetic or geometric. Okay, so since I know this is explicit, I just have to figure out my other key word in there, an add or subtract or multiply, divide. To find some term, add. I'm adding. So if I'm adding and it's explicit, to find some term, I take the first term, I have my common difference, and the amount of times minus the first one. Okay, to find some term, add 3. So I know I'm adding 3 each time, and the first term is 0. So I'm just going to substitute those back in. A sub n equals, my first term is 0, d is 3, to the n minus 1, or you could have written it just simply 3 times n minus 1. Question? I think this is the last one. Okay, so this one was a little bit tricky. I think about half of you got it. All right, so I want recursive, so I figure out, well, I see the word subtract 3 in there, so since I'm subtracting, I'm using arithmetic. So my recursive formula for arithmetic is to find some term, I take the previous one and add my common difference. My common difference, it just told me that, it's -3. So a sub n equals a sub n minus 1 minus 3. Well, what about this? The first term is 7. How come I don't need that? Because it uses the previous term, not the first term in recursive. Recursive just has one piece of information in there, okay? All right. Okay, so go ahead and put your whiteboards away. We're basically doing the same thing we've been doing. I'm just kind of reviewing for this quiz, but our homework tonight is going to be word problems, so we're going to go over that first. Everybody has these tabs taken care of, correct? These are the green ones. Okay, so let's do those today. I'm glad I checked. I'm going to take this out of here, and instead I'm going to write the other rule. So we were using this one to get to find some term. I'm going to also write the other one, like what's on the board. So go ahead and get those in your notebook. Okay, so in a physics experiment, a steel ball is placed at one end of the parabolic track shown below and released. On that initial roll, the ball travels 100 inches. On each successive roll, the ball only travels 90% as far. So if I have only 90% as far, is that going to be addition and subtraction? Am I going to add 90% or am I going to multiply 90%? If I take 90% of something, is that adding or multiplying? Multiplying 90% of something. If I have 100 and I multiply and I want 90% of it, and I multiply by 0.9. We could say 0.90, but you don't need the 0, right? So multiply by, what is that? What is 100 times 0.9? 90. So my first term is 100. So the ball rolls down here, and it's 100 inches. This is a sub 1. And then it rolls back, but as it rolls back, it only rolls to 90. Okay? So my second term is 90. How do I find my third term? You guys are so smart. I'm going to multiply 90 times 0.9. Why not 100 times 0.9? So it's not at 100 anymore, right? It's at 90. So somebody put in a calculator, how much is 90 times 0.9? How much? What? Nobody? What? 71. So my third term is 71. Okay, how many of you thought it was this? 100, 90, 80, 70. What are you doing to each term to get to the next one? subtracting 10, so that's not what we're doing, right? No, this would be arithmetic. We're doing geometric. Okay, so what this would look like, it's 81? Thank you. That makes a little more sense. Sorry, my bad. Six more? Okay, so if you didn't get homework, hold on one second. I'll let you guys do this. So what you're going to do with this homework is first you're going to just decide whether or not you're dealing with arithmetic or geometric. Then you're just pulling pieces of information out of here, right? Like this one has the first term is 100 and R is 0.9. You pull the information out and then do the recursive and the explicit rules. All the answers will, listen you guys, please stop shuffling for 1 second, I promise. Well, not one, but you can get what I'm saying. The answers will be on School Loop, but there's going to be, some of them are going to have two separate answers. Because some of these are a little hard to decipher. Like, if I'm talking about the depreciation of a car, like this one, on number 2, you could say that A sub 1 is the value it is when you first buy it, 25,000, and then after 1 year it was 20,000. Some people would say, well, after 1 year, that should be A sub 1. I would say that one was A sub 1 because that's when you bought it. You see what I'm saying? Like, some people are going to look at it a different way. So there's going to be two different answers on those that are kind of tricky to figure out. Do I start at 25,000 or do I start at 20,000? Does that make sense? You guys are awesome. If you did not get homework, you need to stay back. I need to print one for you. 5?